Hey everyone, welcome to Ethio-Hahu tutorial, where we make learning physics and mathematics fun and easy. Whether you are a high school or a freshman student, you are in the right place. If you are ready to ace your exams, boost your grades, and fall in love with physics and mathematics, make sure to hit that subscribe button and ring the notification bell so you never miss an update. Today, we are going to see about motion with constant acceleration. For motion with constant acceleration, we are going to see different equations of motion that can be used to solve problems related to kinematics of particles. If the acceleration is constant, then the velocity changes with the same rate throughout the motion. That means if an object moves with constant acceleration, the rate of change of velocity is the same throughout the motion. In that case, average acceleration and instantaneous acceleration are the same. Average acceleration is final velocity minus initial velocity v2 minus v1 divided by t2 minus t1, and this is the same as instantaneous acceleration. Assuming that the motion is constrained to move along the x-axis, we can ignore the arrow and let t1 is equal to 0 and t2 is equal to t. v1 is equal to v0 and v2 is equal to v. Having this, a is equal to v minus v0 divided by t. The acceleration of a particle moving along the x-axis is described by v minus v0 divided by t. This is our first equation. To get the second equation, solve for v. From this, a is equal to v minus v0 divided by t. 1 times v minus v0, v minus v0, this is equal to a times t, at. V is equal to, when we bring minus v0 to the right, it becomes v0 plus at. This is our second equation. The third equation, for constant acceleration, average velocity is initial velocity plus final velocity divided by 2. As far as the acceleration is constant, average velocity is defined by v0 plus v divided by 2. This actually holds true for uniform motion too. But we know that average velocity is defined by the time rate of change of displacement. V average is equal to delta x by delta t. But from this equation, this is equal to v0 plus v divided by 2. This implies delta x is x minus x0 divided by t, because t0 is 0, is equal to v0 plus v over 2. If we multiply both sides by t, x minus x0 is equal to v0 plus v over 2 times t. This is our fourth equation. Introducing the second equation into the fourth equation, the second equation is v is equal to v0 plus at. Introducing this into the fourth equation, into this equation, x minus x0 is equal to v0 plus, in v, substitute v0 plus at, v0 plus at divided by 2 times t. Rearranging this, we can come, or we have this equation, x of t is equal to x0 plus v0 times t plus 1 over 2 at square, where x0 is the initial position, v0 is the initial velocity, and a is the acceleration. The last equation, but not the least, solve for t from the first equation. The first equation is a is equal to v minus v0 divided by t. If we solve for t from this equation, t is equal to v minus v0 divided by a, and introduce this equation into the fourth equation. The fourth equation is x minus x0 is equal to v0 plus v divided by 2 times t. Then introduce v minus v0 over a for t and rearrange it to get v squared is equal to v0 squared plus 2a times x minus x0, because x minus x0 is equal to, addition is commutative, v0 plus v is v plus v0 over 2 times t is v minus v0 divided by a. This is equal to, the numerator part is the difference of two squares, v into v0 into v minus v0 divided by 2a. This is equal to v plus v naught into v minus v naught is difference of two squares. V square minus v naught square divided by 2a is equal to x minus x naught. 1 times v square minus v naught square, v square minus v naught square is equal to 2a into x minus x naught. If we bring minus v naught square to the right, v square is equal to v naught square plus 2a into x minus x naught. This is our last equation. Therefore, equations 1 up to 6 are used to solve problems related to kinematics of particles. Having seen these equations of motion, let's do example. At the instant traffic light turns green, an automobile that has been waiting at an intersection starts ahead with a constant acceleration of 2.5 meters per second square. At the same instant, a truck traveling with a constant speed of 50 meters per second overtakes and passes the automobile. A. How far beyond its starting point does the automobile overtake the truck? And B. How fast is the automobile traveling when it overtakes the truck? To solve this problem, let's assume that the automobile and the truck are moving along the x-axis. Therefore, let's fix our coordinate system. Our reference point is the origin. With respect to the origin, they move along the x-axis. The automobile is waiting at the intersection point, and the truck is moving with constant velocity. Therefore, our given are for automobile, initial velocity of the automobile is 0, and the acceleration of the automobile is 2.5 meters per second square, because the automobile is waiting at the intersection point, so that it was initially at rest. The truck is moving with constant velocity of 15 meters per second. After a certain time t, they reach this point, and the distance traveled by the automobile and the distance traveled by the truck are the same. Distance of automobile is equal to distance of truck. Distance of automobile, x of a of t, is equal to x naught plus v naught of a, x naught of a actually, times t plus 1 over 2 a of a t square, where x naught of a means the initial position of the automobile with respect to the reference point, origin. V naught a is the initial velocity of the automobile with respect to the origin, and a of a is the acceleration of the automobile. The initial position of the automobile with respect to the origin is 0. The initial velocity of the automobile is 0. Therefore, we are left with 1 over 2 a of automobile times t square. Distance traveled by the truck when it reached this point, v naught of truck times t. This is equal to v naught of truck is 15 times t. Since distance of automobile is equal to distance of truck, 1 over 2 acceleration of the automobile times t square is equal to v naught of the truck times t. This 1t goes with 1t. Therefore, t is equal to twice of v naught of the truck divided by acceleration of the automobile. This is equal to 2 times v naught of truck is 15 meters per second divided by acceleration of the automobile 2.5 meters per second square. This implies t is equal to 12 seconds. If we multiply 2 by 15 and divide it to 2.5, then we have 12 seconds. The time required to reach this point is 12 seconds, because after 12 seconds, the automobile overtakes the truck. Next, what we do is we need to find distance traveled by the automobile, because how far beyond its starting point does the automobile overtake the truck. When the automobile overtakes the truck, the distance traveled by the automobile is given by this. A distance travel by the automobile when the automobile overtake the truck. 1 over 2 times acceleration of the automobile times t square. This is equal to 1 over 2 times 2.5 meter per second square times 12 second square. This is equal to 180 meters. B. How fast was moving the automobile when it overtakes the truck? The velocity of the automobile when it overtakes the truck is V is equal to V naught of automobile plus acceleration of automobile times t. But the initial velocity of the automobile is 0. Therefore, V is equal to acceleration of the automobile is 2.5 meter per second square times t is 12 seconds. This is equal to 30 meter per second. This is the velocity of the automobile when it overtakes the truck. Therefore, when the automobile overtakes the truck has to travel 180 meters, and the velocity of the automobile when it overtakes the truck is 30 meters per second. And this is all about today. Next time we'll proceed to freely falling bodies. And thank you for watching.